Evaluate sec square theta d theta. This is a definite integral where the upper limit is pi over 4 and the lower limit is 0. Options are given below. The first thing we must obtain is to integrate the trigonometrical function given. Pi over 4, this is 0, sec square theta d theta. To integrate sec square theta, we are going to obtain tan theta, Here the upper limit remains pi over 4 and the lower limit is 0. Now pi is in radian, which is equal to 180 degrees. Pi equals 180 degrees. That is to say, pi over 4 will equals 180 degrees divided by 4. And 180 divided by 4 gives 45 degrees. So at the upper limit, we are obtaining 45 degrees. Whereas at the lower limit, we are having 0 degrees. In upper and lower limit, the next approach is to provide two brackets, where the first bracket represents the upper limit and the second bracket represents the lower limit. So we have this 1 for the upper limit minus this for the lower limit. We are going to substitute. Now in the upper limit, we are having tan. Upper limit is 45 degrees. Remember, pi over 4 equals 45 degrees. So we have tan 45. And in the lower limit, we are obtaining 0 degrees. So that would be tan 0 degrees. Tan 45 degrees is 1 minus tan 0 degrees is 0. So this equals 1 minus 0 equals to 1. The final result is 1 and the correct option is option A, 1. Evaluate the function on the board. Option A, 3, B, 5, C, 2, and D, 6. First thing first, we have to integrate what we have in the bracket. So in the bracket, we have 3 minus 2x. If you integrate this using this principle, in integration, if y is equal to x raised to the power of n, then the y over the x is equal to x raised to the power of n plus 1, all divided by n plus 1. We are going to apply this principle to the integration. Doing this to 3, also the same thing to this. If you do that to 3, we are going to obtain 3x minus, if you do the same thing to this, we are going to obtain 2x raised to the power of 2 all over 2. So 2 will cancel 2. We are going to be left with 3x minus x raised to the power of 2. Since the upper limit is 1 and the lower limit is 0, it is going to be applied here 1 and 0. Next thing is to provide two brackets, where the first bracket represents the substitution from the upper limit and the second bracket represents the substitution for the lower limit. So we have the first bracket minus the second bracket. So in the first bracket, we are going to substitute 1 in place of x. So in place of x here, we have 3 in bracket 1 minus 1 raised to the power of 2. In the second bracket, we are going to substitute 0 in place of x. So that becomes 3 in bracket 0 minus 0 raised to the power of 2. Okay, so 3 times 1 is 3 minus 1 raised to the power of 2 is 1. minus 3 times 0 gives 0, and this raised power of 0 is 0. So everything here becomes 0. We are left with just this bracket, and in this bracket we are having 3 minus 1. 3 minus 1 is equal to 3 minus 1 is equal to 2. So the correct option on the board is option C. Find the y over the x if y is equal to cos x. Option A is sin x, B minus sin x, C minus cos x, D tan x. This is so simple. If y is equal to cos x, the derivation of this trigonometrical function is equal to dy over dx will give you minus sine x. Minus sine x. So the correct option is option B, minus sine x. If y is equal to x squared minus 1 over x, find y over the x. Options are given below. Solution. So we have the function y is equal to x raised to the power of 2 minus 1 over x. Now in indices, if we have, for instance, if we have a raised to the power of minus 1, this can also be written as 1 all over a raised to the power of 1, which is same thing as 1 divided by a. So we are going to apply this rule to the second term on the board. So y is equal to x squared minus x raised to the power of minus 1. At first, we are trying to represent all the terms in their index form. Next thing is to apply this principle. Applying this principle, if y is equal to x raised to the power of n, then the derivation of y with respect to x, which is the y over the x, will equal to n x raised to the power of n minus 1. We are going to apply this to the second and the first term on the board respectively. So dy over the x will equal to 2 times x raised to the power of 2 minus 1 minus, doing the same thing to the second term, we have minus 1 times x raised to the power of minus 1 minus 1. Okay, so from here we have 2x raised to the power of 1, which equal to minus times minus is plus x, and minus 1 gives minus 2. So at this point we are obtaining 2x plus x raised to the power of minus 2. This is the same as 2x plus, now we are changing this person back to this form. Changing this person back to this form rather, obtain 1 over x raised to the power of 2. 1 over x raised to the power of 2. So let us examine options. The option on the board is option D. So a man stands on a tree 150 centimeters high and sees a boat at an angle of depression 60 degrees. Find the distance of the boat from the base of the tree. Option A 10 root 2, B 15 root 3, C 50 root 3, and D 50 root 2. A man stands on a tree 150 centimeters high. This is the height of the tree. Let's call this the height of the tree. At an angle of 60 degrees. Okay, angle of 60 degrees. This angle is alternate to this angle. So that is to say this is 60 degrees. 60 degrees. And the height of the tree is, this is the height of the tree. This is the height of the tree, which is equal to 150 cm. 150 cm. Alright, so this is the height of the tree. This is the boot. This is the boot. And this is the base of the tree, foot of the tree. We are required to determine this distance. So on the diagram, angle theta is given. This part is also given as 150 centimeters. So this part is required. We are going to consider the relationship between this side and this side, between the opposite and the adjacent. And such relationship is called the tan. Using the SOHCAHTOA, the relationship between the adjacent and opposite is called the tan. So we are going to have that tan theta is equal to opposite over adjacent. And opposite on the board is opposite to this angle. So the opposite is 150 centimeters, whereas the adjacent is unknown. What is required? X. The adjacent is x. So tan theta is given as 60 degrees. So at this point, you can make x subject of the formula, making x the subject, x. So over there we have x is equal to 150 divided by tan 60 degrees. That is 150 divided by 60 degrees is a special angle, and tan 60 is equal to root 3. So at this point, we have to rationalize the sum. Rationalization means removing the square root from the denominator of the sum. To do that, we have to multiply both the numerator and the denominator by root 3. Okay, so we have x is equal to 150 root 3, all divided by root 3 times root 3 is 3. It's 3. So 3 goes into 150 50 times, and the answer is 50 root 3. So the correct option on the board is option C, 50 root 3. 50 root 3. If angle theta is 135 degrees, evaluate cos theta. Option A, 1 over 3, B, root 2 over 2, C, minus root 2 over 2, and D, minus 1 over 3. On the board, theta is given as 135 degrees. That is to say, cos theta is the same thing as cos 135 degrees. So the first thing we have to obtain is to split the cos 135 degrees into special angles. To do so, cos 135 degrees is equal to cos, splitting 135 into special angles, it becomes 190 degrees plus 45 degrees. That is the first approach. Now the next thing is to apply the angle formula. The angle formula cos A plus B is equal to cos A times cos B minus sin A times sin B. We are going to express this in in this term. So cos A is cos 90 and cos B is cos 45 degrees. Sin A is sin 90 and sin B is sin 45 degrees. So let us substitute. That becomes cos 90 degrees times cos 45 degrees minus sin 90 degrees times sin 45 degrees. Sin 45 degrees. Okay. So in ratios of special angles, cos 90 degrees is 0 times cos 45 degrees is root 2 over 2 minus sin 90 degrees is 1 times sin 45 degrees is root 2 over 2. So at this point, we are going to obtain 0 times this gives 0 minus 1 times root 2 over 2 is equal to root 2 over 2. So we have 0 minus this is minus root 2 over 2. This is the final result. And the correct option is option C, root 2 over 2. Root 2. The angles of a polygon are given by x, 2x, 3x, 4x, and 5x respectively. Find the value of x. Options are given below. In the question, there are 5 angles given. 1, 2, 3, 4, 5, which is called the pentagon. The formula for sum of interior angle in every polygon is given as sum of interior angle is equal to n minus 2 180. N minus 2 180. So sum of the angles, we have x plus 2x plus 3x plus 4x plus 5x is equal to n minus 2 180 degrees, and n is equal to 5 since there are 5 sides given. Let's add up the sides. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15. So we have 15x is equal to, now n is equal to 5, so it will be 5 minus 2, 180 degrees. So we have 15x is equal to 3 times 180 degrees, and 15x is equal to 540. So making x the subject, 15 and 15, 15 cancels 15. So x is equal to 540 divided by 15. X is equal to 540 divided by 15 is 36 degrees. 36 degrees. So the correct option is option G, 36 degrees. Find the range of 4, 9, 6, 3, 2, 8, 10, and 11. Option A, 11, B, 9, C, 8, and D, 4. To determine the range of a set of numbers, what we have to do is to apply the formula. And the formula is range is equal to highest value minus the lowest. The highest minus the lowest. And the biggest number or the highest number here is 11. So we have the range is equal to 11 minus, and the smallest number is 2. 11 minus 2. So range is equal to 9. Correct option is option B, 9.